Note card 17, transformations. We're going to start working with transforming the parent functions that we've been discussing. And so what we have is a couple of types of transformations that we're going to talk about. We have a vertical shift. You need to know that vertical means up and down. Vertical shift up or down. If it's a vertical shift up, it'll be the function and then outside of parentheses plus c, and that's up c units. In other words, c will be some number, and you'll have to go up so many units. If it's a vertical shift down, it'll be f of x, some function, something going on, and then a minus c outside of the parentheses. That's down c units. Then we could have a horizontal shift left or right. So these work backwards. Typically, when you think of a number line, you think of going right means being positive, or going left means being negative, and that's true. But when we're talking about horizontal shifts, if you have something in parentheses and plus c or plus some number, some constant, that means we're going left c units. It's backwards. If it's minus c in the parentheses, that means we're going right c units, okay? This is somewhat a review from Algebra 2. Vertical reflection. If the entire function is being multiplied by a -1, that means it's being reflected in the x-axis. So what happens is we have the same x values, but your y values become the opposite of what they were. Opposite meaning if you had positive, they're now negative. If they were negative, they're now positive. And a lot of this stuff you may not remember as we go along. That's where we're going to work a couple of examples. A vertical stretch, or first a horizontal reflection. If you have f of negative x, that means that the x value inside of the function is being multiplied by a -1. That means that the graph is going to flip across the y-axis. Okay? And in that case, when it flips across the y-axis, the y values stay the same, but the x values will become their opposites. We could have a vertical stretch or a horizontal stretch. The vertical stretch, if you have some number c being multiplied by the function, that means that you multiply each y value in the function by that c to get the new points. Horizontal stretch, this is a little different. It's kind of like the horizontal shift, right or left. If you have a horizontal stretch, then you have some c in here with x, but it looks like it's being multiplied, but instead you divide by the x value. You divide the x value by c. Okay? Absolute value. If you have the absolute value of f of x, like this right here, you have f of x and absolute value brackets on both sides, meaning the absolute value of all of f of x. That means that all of the y values are non-negative, meaning they're all positive. Okay? And then if you have the absolute value of x, which the function here of absolute value of x, this one's a little different. Regular pre-cal, we may not be doing any of these. Pre-AP, pre-cal, we might have one or two examples of this. But basically what happens, if you have the absolute value of x within the function itself, all the points for non-negative x values or for all positive x values are maintained. So all of your positive x values are maintained and they're reflected across the y-axis. And all the points with negative x values, they're just simply erased. Now that was quickly just kind of reading through the note card and talking about it. Not much of that is going to make sense until we actually do an example or two. So what you'll want to do when you're doing your homework, you'll want to be referring back to this note card, making sure you're doing the appropriate transformation. So let's look at an example. So if I want to talk about doing a transformation of number 1, first of all, a couple of things that we did not talk about. Let me give myself a little room. The first thing that you have to do before you do a transformation, number one, is you must start with the parent function. Must start with the parent function. So, for example, over here at number 1, my function is f of x equals negative, then x minus 1 in parentheses being cubed plus 3. It's very important that you see that this, because I have a to the power of 3 right there, this is a cubic function. So the parent is f of x equals x to the third. That's the parent. And that's where we have to start. The second thing that we need to remember is when we're doing our transformations, we will follow our normal operations. Order of operations, that is. Our normal order of operations. This is very important. Sometimes it doesn't matter what order you go in, just like when you're simplifying an expression. Sometimes it doesn't matter what order you go in, but sometimes it does. And if you don't follow your order of operations, you will have an error, and you don't want that. So we will follow our normal order of operations, meaning parentheses first, and then multiplication and division, and then addition and subtraction. So let's take a look at this example. First of all, I have already let you know that this is a cubic. The parent function is y equals x to the third, or f of x equals x to the third. So the first thing I want to do is graph the cubic. And what I do not want to do is just come up here and say, okay, well a cubic looks like that, and just kind of sketch it on there. No, I want some exact points. And we're not going to be using a calculator here. So what you have to do in order to graph a function, you can graph pretty much any function if you start with an XY chart, a T-chart. And you want to always start with the values for x. You choose those values, by the way, with these values. And the reason you want to choose these values is because it gives you a symmetrical view right here of your origin. It gives you a really good look at your graph. So we want to choose those values. So what I have to do here is I have to find out what is negative 2 to the third, what is negative 1 to the third, and so forth. And so what we're actually doing here is you're actually needing to say, okay, well, f of negative 2 is x to the third, right? This is my parent function I'm looking at. X to the third. Make a set of parentheses using for every place you had an x, and now substitute this negative 2 in. And I need to know what is f of negative 1, what is f of 0, and so forth. So basically f of negative 2 is negative 2 to the power of 3. And if you remember that little rule I told you before, that if you have a negative number being raised to an odd power, your answer is negative. Negative number raised to an odd power, your answer is negative. So I know 2 to the third is 8, so negative 2 to the third is negative 8. Then I have negative 1 to the third is negative 1. 0 to the third is 0. 1 to the third is 1, and 2 to the third is 8. So now I have myself some ordered pairs here that I can plot. So I want to plot these points. And then carefully, I want to sketch this graph. And so there's my parent. And I have these points that I can work with, because that's what I'm going to be using to do my transformations. I'm going to be using these points to do all of these transformations. Okay? So how does this work now? Now that I have my order of my parent graphed, I can use the order of operations to do all the transformations. But first I have to notice what kind of transformations I have taking place here. What I'm about to do, you may not want to write down on your papers as you're following me. I'm going to show you two ways of how to do this. The first way is going to be a bit of a longer way, what some of you may find that suits you better. The final way I'll show you will be a little bit of a shortcut, and you may like that just fine, but I'm going to show you both ways. So hold off until towards the end of the podcast before you do this example with me. The first thing that we must recognize is that I have parentheses here, and inside the parentheses this is a horizontal shift left or right. So I have a -1, and when I refer to my note card, that means I need to go right 1 unit. Those are commas, by the way. This minus sign out here comes next, and that tells me I have a reflection in the x-axis. And then finally, this +3 out here outside of the parentheses tells me I have a vertical shift up 3 units. And I'm going to do this in this order: right 1, reflecting the x-axis, and up 3. So here's how it works. First I'll do the right 1. I'm just going to take each point and I'm going to translate it right 1 unit. Then I can sketch that out as long as it's in a different color to kind of see what I'm doing. And there's that one. That's right 1 unit. Then the next one, I'm going to reflect each point in the x-axis. So this point right here is 8 units above the x-axis, so I need to go 8 units below. This point is 1 unit above the x, I need to go 1 below. This point is on the x-axis, so it actually doesn't go anywhere, it stays there. This point is 1 below, so I need to go 1 above. This point is 8 below, so I need to go 8 above. And I can sketch this one now. This is my third step. And my final step, up 3 units, I work from the previous example that I just did, and I take each point and go up 3 units. Now I only have 2 left here, so 1 above is going to get me 3 above that point. That's 3 above this point. And then I need to go 3 above this point, 3 above here, and I hope I'm not all these colors, and I have colorblind issues, so I think I'm doing fine though. Then this point and 3 above here, and then finally this point and 3 above here, and then sketch this, and the blue one would be my answer. And if you did this method, I would want you to say at the end, blue graph is my answer. Something like that would be fine. Now you may choose to do that method, but make sure you use different colors. I'm going to do a different method. Let me show you what I'm going to do. Let me erase what I have. Oops. Alright, let me start over. Quickly putting my parent function back. Remember, I'm still working with these points that I've plotted. If I go in my order of operations, I can do each point, every transformation in that order. So if I take this point, I need to go right 1, So I need to go right 1 point. Then I need to reflect in the x-axis. So this is 8 above, so I go 8 below. And I go up 3 units. So that point goes right there. You have to be very careful if you're doing this method. You need to double check yourself. So I'll go right 1, reflect in the x-axis, so that's 8 below, and then up 1, 2, 3 units. And then the next point, right 1, reflect in the x, up 3. Right 1, reflect in the x. Sorry, I'm on this point. Right 1, reflect in the x. If I go right 1 here, it doesn't reflect in the x because it's on the x, and then I need to go up 3 units. Then this point, right 1, reflect in the x, up 3. Right 1, reflect in the x, up 3, and then trace it out. And the blue would be my answer. You could choose either one of those methods that you prefer. The critical points are, make sure that first you must start with the parent function. You have to find the appropriate parent function, and it's going to look like this. It's the main version of whatever you have. Next thing is you want to follow the order of operations. So quickly, if I'm looking at this next example, number 2, the parent function would be f of x. That's for this number 2. F of x is equal to the absolute value of x, because I have an absolute value in there. Make sure you can label the appropriate parent function and follow the normal order of operations, and you should be good to go.